Okay, folks, one last video to demonstrate how the area of a trapezoid also is connected to that of a rectangle. Sure, it's a little bit more complicated, but in the end, it still connects directly to the area of a rectangle. So let's check it out. So we'll try it with two different trapezoids. First trapezoid we'll do will look like this. Okay. And we'll go, say, to there, or there works as well. Okay. And just because we will write right over here the name of this, and this type of trapezoid is called a right trapezoid, and that is because it has right angles in it. There's two right angles here. Okay, so what I'm going to do is I'm going to make an identical, of course, right trapezoid, which looks like it's 3 units high and 2, 4, 5 units wide. Okay, so 3 units high, there we go, 5 units wide, coming up to this point here and connecting. And of course, for our aesthetics, we will change the color to the magnificent blue. All right, so like we've been doing, I'm going to take this trapezoid and I'm going to rotate this trapezoid, kind of like so. Let's get it perfect. And I'm going to slide it over here. And I think you know what's going to happen. Of course, two trapezoids that are congruent or identical combine to make a rectangle. Oh, that's a shocker. So what did we do when we did that? Because the formula is a little complicated. But all it is, I'm going to put it in here. What we've done is we've added these two bases together. So this base and that base, which is the short base and the longer base, have been put together to form one long length of the rectangle. And the height of the trapezoid, which is here, also, as you can see, is the height of the trapezoid on this side, which is also the height of the rectangle. So by putting these two bases together, all we did was make a rectangle. So if we could find the area of this rectangle or a parallelogram and then cut it in half like we've been doing, then we would have the area of each of the trapezoids. So the formula looks a little something like this. Okay, so remember, what did I do? And by the way, there's these advanced formulas in here, and you can do this right here. And then it gives us options like this I like because I'm going to need that. And so there's a backslash. We've been talking about that. Backslash, of course, means divide to a computer. So what I did is I put the two bases together. So I'm going to call base 1, which we'll call, I guess, this one here is base 1, and this is here is base 2. Or we can say that this is base 1, and this is base 2. Or this is base 1, and this is base 2. Either way, the two bases of the trapezoid have been put together, and I've added them. Base 2. Wow, spelling looks like that. So base 1 plus base 2. Now, as we were doing algebra, if something's in brackets, then we're going to want to do that first. So I'm going to want to add the length of the two bases together, essentially what we're saying. And then because I'm trying to find the area of this large rectangle, once I know once I know the base length, I would just times it by the height. It's just that the two bases are put together. That's why I added them, to make one long base of the rectangle. Now I need to multiply by the height or the width, which I'll just show as h. Now I could write times height, of course, but if we're going to stay with our algebra, I don't need that multiplication symbol because a variable, in this case h, directly beside a bracket does mean multiply. And then ultimately, that would give me the area of the rectangle. So if I took the two bases and added them together, and then I multiplied by the height, I would know the area of the rectangle. But I want to know the area of each trapezoid. Of course, there's two trapezoids that make up this rectangle. So to find the area of one of them, I would just divide by 2. And so my formula looks something like that. Fancy, huh? So that says base 1 plus base 2 times the height divided by 2 will give us our answer. Okay, well, let's try it out. But even if we were to count squares, right? So we've said that that's all area does. So if we count the squares, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can see there are 9 full squares. Notice there's a half there and a half there, which obviously equals 1. So we're up to 10 full squares. And then right there's an additional half. So the area of this trapezoid is 10.5. And the area of this one should also be 10.5. That means the area of the rectangle should be 10.5 plus 10.5, which we all know is 21. So let's see if we use this formula. If we get an area of 21 for the rectangle, and then let's see if we cut that in half, if we'll get 10.5 for each trapezoid. So I'm going to find an additional text box right here. I'm going to throw it under here. And I'm just going to kind of keep it a little simpler, I think. Base 2, h divided by 2. Okay, so base 1, you can see right here is 1, 2, 3, 4, 5 units long. Okay, so that means I have 5 plus, there's base 2, and it's 2 units long. Okay. Notice that the height is 3 units long, and then I'll be dividing by 2. Okay. So according to BedMass, I should be doing what's in brackets first, which is obvious. Oops. Yeah, that's good. That's 7. And then I will still have the multiply by 3 and divide by 2 if we're going to be doing these in order. Well, 7 times 3, we all know, is 21. And 21 divided by 2, oh, wait for it, 10.5. Big surprise. So the area of each trapezoid is 10.5, which we counted out, and we also disproved using this formula. So all the formula does is it takes the two trapezoids, puts them together to make a rectangle, and then we find the length of the rectangle, which is the two different base lengths of the trapezoid, which is 5 and 2. That makes 7. Well, 7 long times 3 gives us an area of 21. So the area of this rectangle, if we counted all the squares, of course, would be 21. And then we cut it in half, which is divide by 2. Right there, we end up with 10.5 units. Fabulous. That makes sense. Would it also work if we did a different type of trapezoid? Well, of course it would. But let's just do it anyways because it's fun. So we're going to go from here to here. I'm going to go like that. I'm going to go like that. And I go up to here. Let's change the color. How about green? Okay. So let's recreate that identical. By the way, let's grab a text box because this type of trapezoid is called an isosceles trapezoid. Isosceles trapezoid. Interesting word, isosceles, but essentially it means that these two lengths are the exact same. Okay, so two sides are identical inside of this trapezoid. By the way, trapezoids have one pair of parallel sides, so these two lines here are parallel. And if I look at this trapezoid, this pink one, these two lines are parallel, so it has one pair of parallel sides. And if you look at, obviously, it's identical, so these two are parallel. All right, let's go back to this rigid polygon tool and let's recreate this trapezoid. So it's 2 and 2, and then we had this diagonal line cutting across like so, cutting across over here like so, and then coming up here. Okay, and then of course, let's change the color. How about an orange color? Good. By the way, before I move it into place, let's count squares just because it's fun. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 full squares. There's a half, 2 halves there is 1, 2 halves there is another 1, so that's 2. 2 halves there is also 1, so that's 3. So 6 halves equals 3. So in total, there are 15 full squares in these two trapezoids. So obviously, If we now take this orange trapezoid, and of course we're going to rotate it and place it with the other one. Okay, that's not rotating. It actually does matter which vertex you click on for the rotation. But anyhow, and if we slide it over there like that, oh, well, look at that. We've made ourselves a parallelogram. And remember, parallelograms and rectangles are essentially the same thing. A parallelogram is just a rectangle that's kind of been leaned to the side. So if I'm looking at this parallelogram, what is the base of it or the length of it, and what is the height of it? Because if I know those things, I'll be able to find its area. And notice our formula right here, right? So we'll use it. Base 1 plus base 2 times the height divided by 2. So let's try it out. And again, I should be getting the area of this parallelogram should be 30, and the area of each of these trapezoids should be 15 when we do this. So here we go. Base 1, which is right here. So I'll do this, base 1 plus base 2 in brackets times the height. Again, we don't need the multiplication symbol. I could do it like this, but we don't need it, divided by 2. So base 1 is 2 units plus, 1, 2, 3, 4, 5, 6, 7, and 8. I think it's 8. It's hard to tell at this point, but we'll be able to see soon enough. 8 times the height, and the height is 1, 2, and 3 units, and then divided by 2. 1, 2, and 3. Let's hit OK. Let's just verify that, right? So the base is 1, 2, 3, 4, 5, 6, 7, 8. Okay, perfect. All right. So let's double click on that because I want to continue with this. So based on our order of operations, we should be doing what's in the brackets first. So that means 2 plus 8. Well, 2 plus 8 is obviously 10. And I'm leaving the brackets there because this means multiply. If I got rid of the brackets, of course, it might look like that. We know that that is not 103. It's 10 times 3, so it looks like this. 10 times 3, of course, is 30. And remember we said we should have, the parallelogram should have an area of 30? There it is. And then we're going to divide that by 2. We divide by 2, end up with 15. So each parallelogram, or trapezoid rather, has an area of 15 square units. And when we counted those squares plus the halves, we ended up with 15. Again, there's an example of why this trapezoid formula is connected to that of a parallelogram or a rectangle. And that's how we end up with an area of 15 in this case. Hopefully that's helpful. Have fun. I'll talk to you later.